Now we're going to look at probability and z-scores and apply what we have already learned. If you go to the back of your notes, you will find a z-table. Looks just like this one. Now, because of the size of the table in your notes, I've only included the top roughly 15 rows here. So you will have a larger table than what I'm showing you here, but you should be able to recognize the z-table looking at this slide and then looking back at the last page of your notes. What this table tells us is the proportion of scores between any particular z-score and the mean. So let's figure out how to interpret this table. The first thing that we should look at is that very first column, and let's focus just on that for now. If I want to know the proportion of scores between the mean and one standard deviation, what is the proportion of scores between the mean and 1.0? It's 0.3413, or 34.13% of scores. And because the bell curve is symmetrical, the same on both sides, 0.3413 of the scores are both from the mean to one standard deviation above the mean, or from the mean to one standard deviation below the mean. So let's practice with this a bit. What is the proportion of scores between the mean and 0.4? 0.1554. What is the proportion of scores between the mean and 1.2? 0.3849. Or the proportion of scores between the mean and 0.5. 1915. All right. Any particular z-score that has only one decimal place, we can find using that first column. But we've learned to take our z-scores out to 2 decimal places. That's where the remaining columns come in. So if I'm looking for the proportion of scores between the mean and a z-score of 1.2, that value would be 0.3849. But if I'm looking for the proportion between the mean and 1.25, I'm going to need to go over several columns to find that value. And that value is going to be 0.3944. Notice how at the top, the value 0.05 can be added to 1.2 to get 1.25. And the proportion matches up. So let's practice with that. Let's start with this. What is the proportion of scores between the mean and 0.1? 0.3898. How about 0.11? 0.0438. How about 0.13? That's 0.0517. How about 0.19? 0.0753. Are you seeing how this works? How about the proportion of scores between the mean and a z-score of 0.45? We go down to 0.4 and over to 0.45. It's a 0.1736. Let's practice. Find the proportion of scores between the mean and 0.92. 0.3212. Between the mean and z of 1.03. 0.3485. How about 1.28? 3997. And remember, these proportions can be converted to percentages by moving the decimal point 2 points to the right. So a 3997 would be 39.97%. Great. Now that you know how to use the z-table, let's apply what we've learned. Use the z-table to find these scores. What is the proportion of scores between the mean and a z-score of positive 1.00? We've already looked that up. We know that that is a value of 0.3413, or 34.13% of the scores. What I would like for you to do is, here in a moment, pause the video, Complete the rest of these examples using your T-table, and then restart the video, and let's see how well you did. Pause the video and work out the answers in your notes. Restart the video when you're ready to check your answers. Welcome back. Let's see how well you did. For a z of positive 2.0, you should have had a value of 0.4772. For a positive 3, 0.4987. For a 0.11, 0.438. For a z of positive 0.75, 0.2734. For a 1.25, 0.3944. For a 1.58, 0.4429. And for a positive 2.64, 0.4959. So here's a question. All of these z-scores were positive. What if I asked you to find the proportion of scores between the mean and a negative 1.00 or a negative 2.00? Those proportions would be exactly the same as what you have here, because the proportion of scores on either side of that bell curve are exactly the same, because that curve is symmetrical. So let's look at that last example. What is the proportion of scores between the mean and a negative 2.64? Still 0.4959. Now let's do a second example. This time, I want you to identify the proportion of scores above or below these z-scores. Now, this will be much easier if you draw a normal curve to see what part of the curve that you were trying to find. So let's start with this first example. Notice now that the scores are not z equals 1.00, but z less than 1.00. What are the proportions of scores at or below this number? So for a z of 1.00, we know that 0.3413 proportion of the scores is between the mean and 1, but we want to know the scores from 1 and below. In order to figure this out, we need to know that half of the scores are above the mean and half are below. And suddenly, this makes our math much easier. So if we know that 0.3413 of the scores are between the mean and positive 1, and we know that 0.5000 of the scores are below the mean, we simply add those two together, and we would get a total of 0.8413. Let's do another one. A z greater than negative 0.50. So 0.50, we look up on our z table. We want values greater than that number. So we're going to take that proportion, add it to 0.5000, and get 0.6915. The next example is a negative 1.50. So what you should do is look up that negative 1.50, add it to 0.500, and get the score. Now, before you pause the video, let me point out what we would do for some different types of setups. It could be that we'll be subtracting from 0.500. So for instance, the fifth example, z greater than positive 0.80. So what you would do is look up a value of z equals 0.80 in your z table and subtract that value from 0.500. Why subtract? Because we're already considering that half of the scores are above the mean. We know that a certain proportion of the scores are between the mean and positive 0.80, and we want the remainder of that. This is why drawing a normal curve will make this process much easier. You will find that it is easier to visualize the portions above, below the mean, etc. if you draw a picture. Finally, I have a section in your notes called Finding Proportions Under the Normal Curve that will give you additional guidance for each of the conditions under which you might be adding or subtracting z-scores. So now it's time to practice. Pause the video and work out the answers in your notes. Welcome back. Let's see how well you did. For a z-score greater than a negative 1.50, the value is 0.9332. For a z less than positive 0.67, the value is 0.7486. For a value greater than 0.80, 0.2119. Less than negative 2, 0.228. Less than negative 1.01, 0.1562. And greater than 2.00, 0.228. Notice that the proportion of z-scores greater than positive 2 is exactly the same as the proportion of z-scores less than negative 2. If you had any trouble with these examples, go back to finding proportions under the normal curve in your notes and see if you can figure out where you made the mistake and how you can fix that. So now let's do another example.